The monotonic clock module provides a continuous, non-decreasing time source for internal event sequencing and duration measurement. Unlike system wall clock time, which may undergo backward adjustments during NTP synchronization or administrative changes, the monotonic clock advances only forward. The module initializes with a reference epoch value established at system startup, stored as a 64-bit unsigned integer representing nanosecond resolution. This epoch remains fixed throughout the application lifecycle regardless of external time adjustments. Clock advancement is governed by a periodic tick mechanism operating at configurable intervals. The default interval is 1 millisecond, though systems requiring finer granularity may adjust this parameter during initialization. Each tick operation increments the internal counter by the specified delta value. The tick mechanism runs independently of CPU scheduling, utilizing a dedicated kernel timer resource when available. Tick operations are atomic, partial or out-of-order increments are not permitted. The monotonic clock interface exposes three primary operations. The read operation returns the current clock value without modification. The advance operation progresses the clock by a specified duration in nanoseconds. The sleep operation blocks the calling thread until the clock reaches a specified target value. All operations return their results in nanosecond precision. No operation requires external parameters beyond those necessary for the specific function invoked. Clock values are stored using 64-bit unsigned integer representation, permitting a maximum monotonic runtime of approximately 584 billion years at nanosecond resolution. Wraparound conditions do not occur within any practical deployment scenario. The clock does not reset upon thread creation, process restart during graceful shutdown, or error recovery. Value persistence across application restarts is configurable through the checkpoint mechanism described in the state recovery section of this manual. The tick delta parameter governs the magnitude of each increment operation. The default value is 1 million nanoseconds, equivalent to 1 millisecond. Supported values range from 1 nanosecond to 1 second. Setting this parameter to a larger value reduces computational overhead from tick operations, but decreases granularity of time-sensitive measurements. Setting this parameter to a smaller value increases granularity, but requires proportionally more frequent tick invocations. Sleep operations execute via a condition wait mechanism. The calling thread registers its target clock value with a sleep queue. Upon each tick operation, the module evaluates all sleeping threads against the current clock value. Threads whose target time has been reached are awakened and returned to the scheduler. Sleep operations guarantee that the calling thread will not be awakened before the specified target time is reached. The module maintains an internal sleep queue implemented as a sorted linked list structure. Threads are ordered by ascending target wake time. Upon each tick, the module traverses the list from the head, awakening all threads whose target time is less than or equal to the current clock value. This traversal continues until a thread with a future target time is encountered. The operation exhibits linear time complexity relative to the number of awakened threads. Contention for the monotonic clock resource is handled through spin lock acquisition. A call to read, advance, or sleep first acquires the module spin lock. The advance operation increments the counter while holding the lock. All sleep queue modifications occur with the lock held. The read operation requires only momentary lock acquisition to capture the current value. Lock contention is typically minimal in well-designed systems. Furious wake-ups do not occur in the monotonic clock sleep mechanism. A thread will only be awakened when the current clock value reaches or exceeds its registered target value. The module implements a no spurious wake-up guarantee. Code invoking the sleep operation need not loop waiting for condition satisfaction. A single return from sleep indicates that the requested time has been reached. The monotonic clock module supports logical time advancement independent of wall clock time. This feature enables controlled simulation of time passage for testing purposes. When simulation mode is enabled, the tick mechanism remains operational, but external wall clock time is not consulted. The advance operation functions identically in both simulation and standard modes. All module semantics remain consistent regardless of the execution mode selected. Multiple monotonic clock instances may coexist within a single application. Each instance maintains an independent reference epoch and counter. Inter-instance synchronization is not automatic and must be managed by the calling code if required. The module provides no built-in mechanism for coordinating multiple clock instances. Each clock instance consumes a fixed amount of memory regardless of the configured tick interval. Clock value retrieval does not block other operations or threads. Readers never wait for writers, and multiple concurrent reads are permitted. The read operation executes in constant time. No caching layer exists between the caller and the current clock value. Each read returns the most recent value available at the moment of invocation. Subsequent reads always return values greater than or equal to previous readings. The advance operation accepts a duration parameter specified in nanoseconds as a signed 64-bit integer. Negative duration values are rejected with an error return code. A zero duration advance is permitted and results in no change to the clock value. Advance operations are recorded in the operational log if logging is enabled. The log entry includes the previous value, the delta applied, and the resulting new value. Overflow protection is implemented through implicit saturation. Advance operations that would exceed the maximum representable value are clamped to the maximum 64-bit unsigned value. A warning message is logged when saturation occurs. This behavior prevents integer overflow but does not result in an error return. Subsequent advance operations following saturation have no effect. The clock remains at the maximum value indefinitely. The module publishes statistics through a standard metrics interface. Exported metrics include the current clock value, the configured tick interval, the number of active sleepers, and historical tick operation latency. Statistics are updated continuously and may be queried at any time. No locking is required to read statistics. Values represent snapshots at the moment of retrieval. Statistics reset upon module reinitialization. Module initialization occurs once during application startup. The initialize function accepts optional configuration parameters including the tick interval and simulation mode flag. Default configuration is used if no parameters are provided. Initialization is not idempotent. Calling initialize on an already initialized module returns an error. Module termination releases all allocated resources and unblocks any sleeping threads with an error status.